Hi, I'm Ned, and I make games. Today I want to make a simple shader graph and demonstrate how to set property values from a C# script. It's a relatively simple process, but there are a few wrinkles which I aim to straighten out. Along the way, I'll make a simple script which creates randomly colored ripples on a mesh, centered on wherever you click. Before we get to the nitty-gritty, I want to thank you all for watching. I publish weekly game development tutorials here, so please consider subscribing and turning on bell notifications. Also, if you haven't, check out my channel's community tab. I post tutorial updates and sneak peeks there. Alright, on to the fun part. I made this project in Unity 2020.2.1f1 and Universal Render Pipeline 10.2.2. Although the principles here should work with any version of the shader graph, and even the high-definition render pipeline. Check the video description for any updates if you're using a newer version. Our goal is to create a material that changes color when clicked. We want the color change to propagate like a wave or ripple, starting at the position and time that we click. A shader graph will handle that effect, and we'll define several properties inside that we can set from an outside C# script. This script will listen for mouse clicks and set properties accordingly, initiating the wave. Let's get started by setting up the Universal Render Pipeline by downloading the package, creating a settings asset, and setting it as the active render pipeline in project settings. Create a test scene with the object you'd like to hold the material. It can be just about anything, but for this tutorial, make sure it's all one mesh, and that the mesh renderer and collider are on the same game object. Then create a lit shader graph asset. Open it, and inside we want to calculate the ripple boundary first. Start by taking the distance between a world position node and the ripple center property. The boundary should expand as time goes on. Subtract a start time property from the time node, and multiply by a ripple speed property. When you multiply time by speed, you get distance. This is the distance of the expanding wave front from the center of the ripple. So divide the two distances together to get a blending value. We want more control over how the wavefront blends with the base color. Let's use a smooth step node for that. It clamps the value inside the edges, but returns a smooth curve when the value is between them. Now create a smoothing property, feed that into a 1- node, and then into the edge 1 field of the smooth step node. Set edge 2 to 1 and n to the distance quotient. Finally, create a blend node in overwrite mode and feed in the two colors and the blend value. And put that into the base color of the master stack. Here's the magic that enables property edits through C#. They're reference names. In each property settings, set the reference field to match the property's name. It's customary to start a property reference name with an underscore, so I'll do that here. And with that, we're done with the graph, so save the asset. Back in the scene editor, create a material for our shader and apply it to the mesh. You won't see much yet because it's difficult to sync the start time correctly in the editor. Let's move on to the script. Create a C# script and open it. Inside, create a private instance variable to hold the material, and in the start method, retrieve it from the mesh renderer component. In update, we'll listen for the player to press down on the left mouse button, and then raycast to see where the mouse is in relation to our mesh. If you're new to raycasting, I'll link a good article about it in the video description. Regardless, write this cast-click-ray method to calculate the ray and then cast it. If it hits a collider connected to this game object, we'll call the startRipple method, passing the collision position. In startRipple, we can set the ripple center position and start time properties by calling setVector and setFloat on the material. The first arguments are the reference names set in the graph, and the second arguments are the values that we want the properties to contain. The ripple center is the raycast hit point. As for the start time, we can use time.time. It's always in sync with the time node in the shader graph. Calling it here will set the property to hold the current time. Alright, back in the scene editor, add your interactive ripple controller component to the mesh game object. Make sure it's on the same game object as the mesh renderer and collider. Then press play and click on the mesh. There we go, there's a ripple. Let's make it a little more interesting by changing the ripple color each time we click. Go back to the script and add a private previous color property. In the start method, get the current base color from the material to initialize that variable, and then set the ripple color to match. This makes sure that a ripple doesn't spontaneously display immediately when you start up the game. Then, in Start Ripple, generate a random color for the next ripple. Set the material's base color to the previous color and the ripple color to this new random color. Then store the new color in the previous color variable. Return to the scene editor and press play. That's so satisfying to play around with. Of course, if you click too fast, the effect ends early, but I'll leave fixing that as an exercise for you, dear viewers. I do, however, have a few more tips to share. You may notice that modifying the material in the C# script permanently changes it, and these changes even persist between play sessions. If you don't want this to happen, you have to copy the material and assign it to the renderer at runtime. In C#, the process looks like this. Remember to also destroy the duplicate in onDestroy method, so extra materials don't build up in your game. Now, each time you exit play mode, the material will reset correctly. It's not so much of an issue for this script, but if you set the material properties very frequently, there's a way to optimize the process. Unity stores shader variables using an integer ID, and whenever you pass a reference name to set, float, etc., it must translate that name to the ID. We can do that ahead of time using shader.property2id and then store the results. In your script, create a private structure to hold any needed property IDs, then add an instance variable of that type. In the start method, instantiate the storage structure and initialize it by calling property2id for each property. Now, in Start and Start Ripple, replace the reference name strings with these cached reference IDs. And that's it. Like I said, for this project, you're unlikely to notice a difference in performance, but it's another tool you can use to optimize your game should the need arise. And with that, I think we're done with this project. Try to get in the habit of setting reference names in your graph properties. Then you'll be able to script them right away if you need to. And if you ever start writing code shaders, you can use the same methods on the material class to set properties for them too. It's quite powerful. Thanks so much for watching. If this tutorial whet your appetite and you're interested in more shader magic, check out my other videos. I have tutorials on toon shaders, outlines, grass, and more, and I'd really appreciate it if you could leave a like. It lets YouTube know to recommend this video and it really helps out the channel. If you have any questions or suggestions, please don't hesitate to leave a comment. I do read them all. How do you plan to apply this tutorial to your project? Is there a topic you'd like to see me make a tutorial about? Thanks again for watching, and make games.